So in this video I'll be telling you the conditional identities involving the angles of a triangle. Now see, the identities involving sines and cosines. Now in this case I will be giving you directly the example, I will be solving the examples, and this exactly method you should follow when you get these questions in the paper. Now our first example is, if a plus b plus c is pi, you have to prove that sine 2a minus sine 2b plus sine 2c is 4 cos a sine b cos c. You have to prove it. So these are the identities which involve sines and cosines only. Okay, so we start with the LHS. Now LHS is sine 2a sine minus sine 2b plus sine 2c. So we will 4 prove that sine 2a minus sine 2b plus sine 2c is equal to 4 cos a sine b cos c. Now LHS. Now we actually now starting with LHS. Okay, sorry, starting with LHS. This will be sine 2a minus sine 2b plus sine 2c. Okay, now sine a minus sine b, by formula we know that sine a minus sine b is sine I'll show you that thing, sine c minus sine d, sine c minus sine d, sine c minus sine d is 2 cos c plus d by 2 into sine c minus d by 2. So sine c minus sine d is 2 cos, we'll start writing 2 cos. Now see, this is 2a plus 2b by 2, which will be a plus b into sine, again 2a minus 2b by 2, taking 2 common is sine a minus b plus sine 2c is, you can write 2 sine c cos c. This is directly by the formula. Now we know that a plus b plus c is pi. So a plus b is pi minus c. So writing this as 2 cos pi minus c into sine a minus b plus 2 sine c cos c. Okay, now pi minus c. Now see, pi minus c, this is in second quadrant. In second quadrant cos is negative, though it will remain cos, but this will be minus 2 cos c into sine a minus b plus 2 sine c cos c. Now you can take minus 2 cos c common from here. So taking minus 2 cos c common, this will be sine a minus b minus sine c. Now again minus sine c, again c can be written as pi minus a plus b, by this pi minus a plus b. Okay, so writing again, so this will be minus 2 cos c sine a minus b minus of sine, this is what, pi minus a plus b. Now see, pi minus a plus b is basically again in the second quadrant only, where sine is positive. So this pi minus a plus b is sine a plus b. So minus 2 cos c sine a minus b minus sine a plus b. Now sine a minus sine b. Now if you remember this, sine a minus b minus of sine a plus b, sine a minus b minus of sine a plus b. So this will be negative of minus cos a sine b. So this will be minus 2 cos c, this will be negative of 2 cos A sin B, which is 4, now rearrange it, cos A sin B cos C, which is equals to, 4 cos A sin B cos C, just rearrange it, which is equals to the answer. So moving on to the next example. If A plus B plus C is pi, prove that cos 2A plus cos 2B minus cos 2C equals 1 minus 4 sin A sin B cos C. Starting with the LHS only. See, cos 2A plus cos 2B minus, see, cos 2C is basically like cos 2x, is 2 cos square x minus 1. So this will be 2 cos square C minus 1, putting this in bracket. Okay, I have expanded this, now I have to expand this. Cos A plus cos B plus cos B is 2 cos A plus B by 2 into cos A minus B by 2. So basically this will be 2 cos A plus B. Why? Because 2A plus 2B by 2, you take 2 common, 2A plus B by 2, 2 will get cancelled. 2 cos A plus B into again cos A minus B. That will be again 2A minus 2B upon 2 cancel. Minus 2 cos square C, this is plus 1, opening the bracket. See, plus 1. Okay. Now A plus B again, that can be written as pi minus C. So this is 2 cos pi minus C into cos A minus B minus 2 cos square C plus 1. Now 2 cos pi minus C, basically since it's pi it will remain cos only, and that will be negative because that is in the second quadrant. So you have minus 2 cos C into cos A minus B minus 2 cos square C plus 1. Okay, now what we can do is that we can write 1 over here, so 1, and you can take minus 2 cos C common, minus 2 cos C common, so this will be cos A minus B, and minus minus become positive, plus cos C. Now again C can be written as pi minus A plus B, so this will be 1 minus 2 cos C cos A minus B plus cos, this will be pi minus A plus B. Okay, pi minus A plus B will be cos minus, because in second quadrant, minus cos A plus B. So 1 minus 2 cos C, this is cos A minus B, minus of cos A plus B. Now cos A minus B minus of cos A plus B. Use this formula, cos A minus B minus of cos A plus B, which is 2 sin A sin B, which is 2 sin A sin B. So 1 minus 2 cos C, so this is 2 sin A sin B. This is 1 minus 4 sin A sin B cos C. Rearranging them, which we had to prove. Okay. Now the other case is that which involving like that involves, just a second, that involves like the squares of sines and cosines. So basically change the squares of sines and cosine into cosines of double the angle by using the formula, like cos square theta is basically 1 by 2, 1 plus cos 2 theta. Similarly Sine square theta is equals to 1 by 2 1 minus cos 2 theta. So this is how this is done. So again you will get to know by the example. Now see, now your triangle ABC, you have to prove that cos square A plus cos square A plus pi by 3 plus cos square A minus pi by 3 equals 3 by 2. Okay, so starting with the LHS only. So this is cos square A plus cos square A plus pi by 3 plus cos square A minus pi by 3. So using the formula of cos square theta as half of 1 plus cos 2 theta. So cos square A can be written like this is 1 by 2 1 plus cos 2A. Okay, this is again cos square theta, considering this as whole theta, this is 1 by 2, use the bigger bracket, 1 plus cos, now whole by 2, so this will be 2A plus 2 pi by 3. Okay, then again plus half, big bracket, 1, I am writing here, plus cos, this is cos, this will be 2A minus 2 pi by 3. This is how you write. Converting that cos square A as half of 1 plus cos 2A. Okay, now the next step. As you know, this is when you open this bracket, this will be 1 by 2 plus half of cos A, again this will be 1 by 2 plus half of this thing plus this will be 1 by 2 plus half of this thing. So 1 by 2 plus 1 by 2 plus 1 by 2 is basically 3 by 2 plus this is half of cos 2A plus half of this thing, half of cos of 2A plus 2 pi by 3. Okay, then plus cos, taking half common from this, cos of 2A minus 2 pi by 3. Okay, now you got this. So applying this formula, cos A plus cos B, cos A plus cos B is cos, sorry, this is cos A plus cos, sorry, this is actually cos A plus B plus cos A minus B, cos A plus B plus cos A minus B. This is the formula, cos A plus B plus cos A minus B, cos A plus B plus cos A minus B, which is equals to 2 cos A cos B. So now use the formula. This is 3 by 2 plus half of cos 2A. Okay, now using this formula plus this was what, cos A plus B plus cos A minus B, which is cos A cos B, twice of cos A cos B. This is 1 by 2 2 into cos A was cos 2A cos 2 pi by 3. Actually this and this will get cancelled, so again writing this thing. So this is basically, oh sorry, if you haven't seen this, half, this is cos 2A cos 2B, cos A cos B, this is A, this is B, cos A plus B plus cos A minus B is 2 cos A cos B. So this is again 3 by 2 plus half of cos 2A, 2 will get cancelled, plus cos 2A cos 2 pi by 3. Now see, what is cos 2 pi by 3, which is actually cos 120 degree, which is minus 1 by 2. So this is 3 by 2 plus half cos A, this is minus 1 by 2, minus 1 by 2 cos, sorry, 2A, this is cos 2A. This and this will get cancelled, you get 3 by 2. Sorry, this was cos 2A. Now, identities now involving tangents. Now in tangents, what we do is that we directly use the formula, for example, like tan and cot. This applies for both tan and cot. You know the formula of tan and cot. Now we have the example as tan a plus b plus c is pi. Prove that cot a by 2 plus cot b by 2 plus cot c by 2 equals cot a by 2 into cot b by 2 into cot c by 2. We know that a plus b plus c equals pi. Okay, so you can write this as a by 2 plus b by 2 equals pi by 2 minus c by 2. Yeah, applying cot on both sides, so this will be cot a by 2 plus b by 2 equals, this is cot, this is pi by 2 minus c by 2. So using the formula of this, see, cot pi by 2 minus c by 2 will make it tan c by 2. So this is equals to tan c by 2, because this is pi by 2, first quadrant, positive. Using the formula of cot A plus cot B, it's a cot A cot B minus 1. So cot A by 2 into cot B by 2 minus 1 upon cot A by 2 plus cot B by 2 equals, now tan c by 2 can be written as 1 upon cot c by 2. Okay. Now cross multiply. So this times this is cot a by 2 plus cot b by 2 equals, this is cot a by 2 cot b by 2 cot c by 2 minus cot c by 2. So just take minus cot c by 2 that side, we will be at our answer. So cot a by 2 plus cot b by 2 plus cot c by 2 equals cot a by 2 cot b by 2 cot c by 2. So these are actually the examples that you should follow involving the angles of a triangle.